Okay, so we're going to do some more examples where we're rationalizing the denominator of our fraction, meaning we're getting rid of that radical and just leaving a rational number there. In our case, it'll be integer values in each of these. In the example that we just did, we said square roots. Square roots are easy. They're nice to work with because if I take a square root times itself, then it goes away. And I just have whatever number or term or expression happen to be there. So the square root of 6 times itself is just going to give me 6. On the top, I have 8 times the square root of 6. And again, the best I can do is like taking a 4 times an x. I just write 4x. Okay, I can't combine the 8 and the 6 together in any way, not any correct way. From here, though, I look and I say, well, the number's outside the radical, meaning the 8 and the 6. That's not in lowest terms. I can take a factor of 2 out of the top and 2 out of the bottom. And so I can leave my fraction in lower terms and call it 4 square root of 6 over 3. That's the reduced, accepted form of that fraction there. If we move to a different root, something like a cube root or a fourth root, notice, and we had this example on the other page, that if you just multiply the cube root of 2 times itself, while this still would be an equivalent fraction, okay, this would still be a true statement, when I multiply the stuff together on the bottom, I still have a radical there. Okay, cube root of 4. Cube root of 4 doesn't break down, doesn't simplify anymore. So that means I have to get a little bit more creative. I have to be able to put the puzzle pieces together because my goal is to release that 2 and to help it escape out from under that radical. So from the other chapters, when we were working along the way, we said if we have a cube root, then we need a total of 3 factors to get that guy out from under the radical. Okay, I only have 1 here. So if I have 1, 2, and I need a total of 3 of them, that means I need 2 more. If I started with 1 and I need to get to 3, that means I need to put 2 more down there. As long as I multiply the top of the fraction and the bottom of the fraction by the same thing, as long as I multiply that fraction as a whole times the number 1, I've changed the way it looks, but I'm not changing its value. That means on top, I have 3 times the cube root of 4. I'm going to put that 2 squared back together since nothing's going to be set free there. But on the bottom, I now have the cube root of 2 cubed. And the cube root of 2 cubed is just plain old 2. Now because the 3 and the 2 have no factors in common, more exciting than 1, that is in lowest terms. And so I circle 3 times the cube root of 4 all over 2. When we have the fourth root, okay, fourth root of 5, I have 1 factor of 5 here. Let's do that all in blue. I have 1 factor of 5. If I'm looking at a fourth root, that means I need to have a total of 4 of something before it can come out from under the radical. So if I have 1 and I need to get to 4, that means I need to put 3 more on the bottom and therefore 3 more on top. Again, the 7 and the 5 don't have any factors in common. 7 over 5 is in lowest terms. So even though 125 seems like a big number, it's really not something that we can simplify if I say it's really not. There's not enough 5s to get it out from under. So that's really the best we can do with it. All right. On this page here, okay, if you don't get too dizzy. On that I have some other examples. You can pause the video. The black on the left is what we started with, and then you can look at the blue that we had to put in there to get to where we're going in the end. There was one more example, one more kind of situation. me see would like. Okay, anyway, it's not a good way for me to only show you part of it and not all of it. If I have a sum or a difference of square roots on the bottom of that fraction, instead of just a single radical term like in the 4 examples above or the page before. Okay, notice there at the left I said, well, let's start by multiplying top and bottom of that fraction by square root of 5. That's what worked at the top. That's what worked on the other page. If we do that, we get the step here in black. Which, yes, it did get rid of that square root of 5 and turned it into plain old 5, but now it has a square root of 10. If I try to do this again, and I multiply top and bottom times the square root of 10, notice that what happens is now I have 5 square roots of 10 on the bottom minus a plain old 10. It's just going to hop that radical back to the other term. What that means as a whole is that this is not going to work. I have to be more creative than that. So if I have a sum or a difference of square roots, or that involves one or more square roots, but a plus sign or a minus sign on the bottom, and I need to get that radical off the bottom of the fraction, we're going to use what's called the conjugate of that expression. And the conjugate means that I'm going to keep the square root of 5 and I'm going to keep the square root of 2. But instead of the minus sign in between, I'm going to change it to a plus. When I do that, go ahead and distribute. Pause the video for a second and distribute. Actually, don't distribute on the top. Just write 8 times that stuff. But on the bottom is where I want you to distribute. Okay, use FOIL, expand that out, combine your like terms, and see what happens. Okay, pause the video and try it first on your own. And then unpause it, we'll get to the punchline. When we expand that bottom expression, our outside and inside terms go away. What we've done there is create a difference of 2 squares. And when we create that difference of 2 squares, the 2 radicals that we didn't like to begin with, I'm sitting here pointing and you can't see my finger, those go away. And all that we're left with on the bottom is 5 minus 2, which is 3. And again, I had a slip of the tongue where I said distribute on the top. Please don't ever distribute on the top until you get to the very end, because occasionally, right here, this piece will reduce. Okay, in our case, it didn't, but if that 8 was distributed through, you'd have had to factor it back out and then take care of it. And we don't want to have to do extra steps if we don't have to. So the conjugate is actually going to be, I say become our friend. It's not our best friend like factoring is our best friend, that we have to use it all the time, every class anymore. But the conjugate is something we'll use again later in a couple of sections down the road. It's something that you'll get to use in another algebra class. In trigonometry, right now we're working using the conjugate of things that look a little nastier than this. Calculus also. We like the conjugate because he helps us out. So look over these examples, spend some time with them. Please get a hold of me if you need something from me.